All right. Good morning, good evening, good afternoon to you all. My name is Gloria. I'm here with the Get Coin team, and I'm here with Joe from the Algorand Foundation. And Joe's going to be going over Beaker and testing. And before we get started, I just wanted to let you all know that this session is going to be recorded, so you'll be able to rewatch this session and all of the other previous sessions on the Get Coin Media YouTube channel. There'll be a playlist that's the Greenhouse Hacks too, and you'll be able to find all of the videos there. Second of all is if you have any questions, feel free to drop them in the chat or in the Q&A. I will be monitoring both of them. And last but not least, in the chat, feel free to say hi. Let us know what you're working on and where you're watching from. It's a good way for y'all to get to know one another, and it's a great way for us to get to know each and every one of you as well. With that, I'll go ahead and turn it over to Joe. And Joe, you can go ahead and get started.
All right, thanks, Gloria. So, as Gloria mentioned, in this session, we're going to be going over Beaker. And for those that don't know, Beaker is a framework for building smart contracts. So, if you're not already familiar with PyTeal, which is our Python library for writing smart contracts on Algorand, I recommend you stop watching this session and go back and watch our Intro to PyTeal session. You can also go on YouTube and find our Zero to Hero PyTeal course. And if you look back at our learning resources session for Greenhouse Hack 2, I have links to multiple resources for learning about PyTeal. So this session is going to be expounding upon the knowledge that you learn with PyTeal and showing you how to be a more effective developer with Beaker. So Beaker is basically, like I said, a framework that builds upon PyTeal and creates a lot of abstraction that makes writing the smart contract easier, and then also makes interacting with the smart contract after you write it easier. So if we go over here in the terminal first, look, I am in this Beaker calculator repository. So if you go on GitHub, it is Algorand DevRel / Beaker calculator. And we can share links to this in the chat and then after the session as well. So the Beaker calculator is a fairly simple smart contract. As the name suggests, it's a calculator. And in this repository, we have an example of the Beaker calculator, or the calculator written in PyTeal. So just regular PyTeal, no Beaker. It written with Beaker, and then it written with Beaker for testnet. So by default, Beaker kind of assumes you're working on a local sandbox network. And we also include an example to show if you want to change that to testnet. So first, let's get started on why you want to use Beaker in the first place. And a just very simple way to start off is that the Beaker code that you need to write in order to do certain things is just less complex and less lines of code. So if we go over here in our terminal and I run this command scc, and this is basically for calculating the complexity of a given repository. If I run calculator PyTeal, we'll see that there's 156 lines of code that the tool assigns a complexity of 8 to. And there's also some other information down here. Again, this is kind of subjective, but this tool is really useful for just getting a general idea of how complex a given code base is. So then if I do the same thing on the Beaker directory, I can see I have way less lines of code, and it's given a complexity of 1. So again, comparing PyTeal to Beaker, just based on lines of code, Beaker is significantly smaller and less complex. Okay, so that alone obviously is enough information for you to decide whether you want to use Beaker. So let's actually get into the smart contracts itself. So first, we're going to start off in our PyTeal contract. If we look over to contract.py, here we can get a general example of what the contract is doing. So again, if you're not familiar with PyTeal, you probably want to brush up on that first. But very briefly, here we have our router. So this is basically the object that will be routing our ABI methods and bear action calls. And then we have our method definitions here, with this router add to add them to the router. So here we have our add method, takes two uint64s, adds them, and returns the uint64. Subtraction, well, you get the idea. So once we define our actual contract in Python, so our router and our router methods, then what we need to do is go over here and call our router compile program to generate our artifacts here. So when you're working with PyTeal and you want to interact with the contract, you need to explicitly write out files for the contract itself. So here we've written out our approval program, clear program, and our ABI JSON. And this is used if we go over to this interact py. This file here is basically interacting with a smart contract. So here, as you can see, like our first definition is creating the app, and then we're going to be basically submitting transactions to the network based on this app that we want to create and interact with. And it's, as you can see, we have 135 lines of code here. So basically, in our create app, we need to specify the on complete. We need to get our suggested parameters. We need to manually form the entire transaction here. And we need to explicitly sign it with our private key. We need to extract the transaction ID. And then we explicitly send it. And then we have to do this await for confirmation. And then we can display the results. And our compile program here, which takes in basically the teal code and then compiles it for what the AVM will eventually read. We need to explicitly do that as well when we create our smart contract. So here we're doing another API call, compiling this teal, and doing that all manually. So now for our actual program that we're running, we're defining our LOD client. So this is going to just be the connection information for Sandbox. We're going to call this get accounts function, where if I open up the definition here, this is an additional Python file with helper methods for getting accounts and their secret keys from KMD or from the sandbox. And this is not too complex, but it's really annoying because you pretty much have to do it every time you're testing or interacting with sandbox contracts. So this is the helper function that you need to define for that. And then, so we're getting our accounts, and then we're going to be reading our approval and clear programs. And then we're going to be compiling them. We have to explicitly define our schema. And then we can finally call the create app. So we did all of this line of code before we even created our app. So before we can even interact with the smart contract, we needed about 100 lines of code here in this Python SDK. And in other SDKs, it's pretty much the same in order to interact with the contract. And then here, we're going to be reading from the ABI JSON and using the atomic transaction composer to add method calls and then execute them. Okay, so obviously that is kind of a lot of code just for making sure a smart contract works. Um, you know, you're looking at like 135 lines of code for very simple functional testing, making sure that every method is callable. And obviously this is kind of a lot. And you can imagine as you have more complex, like here we only have four four methods that we're calling. So the contract isn't too complex. It's only four transactions, but you can imagine if you want to test more complex more complex contracts, then you're going to be running into um, a lot more lines of code. Okay, so that's with PyTeal. And again, just to recap, with PyTeal, you need to explicitly write out your approval and clear programs, your JSON, and then you need to write a helper function to interact with Sandbox, and then you need to go through all the steps of composing all the individual transactions and then sending them and signing them. There's a lot of friction between writing the contract and testing the contract and interacting with the contract. So now let's take a look at Beaker. And if you remember from the output earlier, Beaker is significantly simpler than PyTeal. So if I look at Beaker here, right away you can tell we have all these files needed to interact with our contract with just raw PyTeal, and of course the Algorand SDK. And here we just have a single file that is 64 lines of code. So about half the lines of code of just our interaction script. And this contains both interaction and definition of the contract itself. So before I go into the exact details of how a Beaker application is laid out, you can see here I just have this class called calculator that has the methods, and that's pretty much it in terms of smart contract definition. And then our demo function, you can see here we're getting our client just from this sandbox method, which is provided by Beaker. And we're getting our accounts again just from the sandbox method. We don't have to manually write out that long function. We specify our app client, which I'll talk a little bit about what this means, but this is basically the object we interact with to call the smart contract. And then to create it, it's just a single line of code, app client dot create here. And that's all we need to do to create it. We just create the app client and then call app client dot create. And there you go. There's your contract created. And if we want to call other methods, so we have a bunch of other methods here in this contract, or 4 other methods in this contract, much like create, it's just a simple app client.call, specifying the method, passing in the arguments, and then that's returning the result here. And that's pretty much it. So, and then of course, our entrancy into this is we're going to be printing the the information if we want it, and then calling this demo to actually interact with it. So, as you can tell, just at a high level, Beaker is much more simpler in terms of like end-to-end testing, like writing the contract and then interacting with it. So, this repository is just a good example of that. And for a little bit more hands-on of how Beaker actually works, I'm going to be using another repository. So if you go to the Algorand DevRel page and then go to Beaker-auction, this is another repository we have focused on Beaker. And this time it is just Beaker. Well, we don't have any raw PyTeal in here. And our contract is defined in this auction.py file here. Okay, so if you want to create a Beaker app, first, of course, you need to import Beaker. But then, in order to just kind of set up the scaffolding, you just create a regular Python class and have it inherit from application. And application is a Beaker class. So if we were to take a look at this Beaker class, this application class basically has a bunch of methods for um, for interacting with the smart contract itself. So this application is going to be what we're inheriting from for this class to signify to Beaker that this is a Beaker smart contract. And then we can get started with defining our methods. Okay, so first thing you might notice is that we're defining our global bytes as and global ints, so our global state, as properties of the class itself. So what this line of code is really doing here is saying in our global state, we're going to have a key named owner. And then this bit right here is some typing, some Python specific typing. What we're basically doing is we're saying this owner key must always be an application state value. And an application state value is a type provided by Beaker that tells us that this owner is a state value for our application. And then here we can also see that our type is tealtype.bytes. So what this means is in our contract, we're going to have a global state key called owner. And in that key, the value for that key is going to be some bytes that we're saving. And it's the same thing for highest bidder and same thing for auction end, except we're going to be saving UN64, and same thing for highest bid. So if you notice, compared to PyTeal, where you have to do explicit app.global_gets or app.global_put, here you're just interacting with the property of the class itself. And I'll show what that looks like in the code. But if you're already familiar with Python, you can already probably tell that's a lot easier than having to manually call app.application or app.global_get and app.global_put and manually specifying the key every time and making sure that you have the right key every time. With this, it's a type safe way of defining global state. And the nice thing about this is since we're defining our properties on the contract, Beaker, when it creates that app client, that again, I'll talk a little bit more about afterwards, but when it creates that app client that we can use to interact with the contract, it automatically knows our um, global schema. It sees that we have two properties, which has a stack type of bytes and two properties with a stack type of UN64. And it knows that our global schema is going to be 2 bytes and 2 ints. And a very similar pattern is used for local state as well. Okay, so that's global state, and that's personally one of my favorite things about the abstractions of writing Beaker itself is that you're saving global state as actual properties on a class rather than just having to like save the byte string as a constant or manually type it out every time. So this makes it a lot easier. Now let's go down into our first method here. This is our create method. And as the name suggests, this is going to be what we're calling when we create the contract. So uh, this create method, what it does is it basically sets up our local state or global state. I'm sorry. We have self.owner.set. And what this is doing is going up to this owner key. So in our global state, we're setting the owner key value to equal transaction.sender. So what this is doing in our global state, it's setting owner equal to transaction.sender. And the same thing is being done here. We're setting highest bidder just to an empty string here because no one has bid yet, obviously. And then we're setting our highest bid in auction end to 0 because the auction hasn't started yet. Again, interacting with global state, it's simply just calling that property and then calling dot set. And as you can imagine, which you'll see later, if you want to get it, you would just call auction end dot get. And what this create decorator does is it tells Beaker that this is the method we want to be used upon calling .create on our application client. So when we actually create the contract and we tell Beaker we want to create the contract, we know that this is the method that we're ultimately going to be calling. Okay, so let's look at our first actual method here with some arguments. We have start auction, and start auction takes in 3 arguments here. We have payment. So this is going to be a payment that is used to fund the contract. So before anyone can send, a balance to the contract, it needs to have 100,000 micro algos. So we want to make sure that we have that transaction being done atomically with our start auction call. And then we're going to have our starting price here, which, as you can guess, will specify the starting price of the auction. And then our length here, which will be the length of the auction in seconds. So for actually getting the value from an ABI argument, again, this is much like what you would do in PyTeal itself without Beaker. But here you can see we're doing payment equals payment.get to get the value stored in that argument. And then we're going to just run through some assertions here. I'm not going to go too in depth on what the actual logic is doing because that's mostly just PyTeal at this point. But I will be going over again. Here you can see we're using this self.auction end set. And this basically means set our auction end global key to the latest timestamp plus our length. And then we're setting our highest bidder or highest bid to our starting price. And if you notice, we have this external decorator. And this is basically telling Beaker that start auction is a function that we want to call externally. It's an ABI method that other people might be wanting to call. Now, the opposite of that here, we have this internal decorator. What this internal decorator basically means is that this is not an ABI method that someone would externally call. This is just a method that we use within our own contract. And here it's a method for sending an inter-transaction payment given a receiver in an amount. Yeah, and again, this internal is just specifying this isn't an external method that should be exposed via the ABI interface. This is simply an internal method, basically like a helper method that we use in other external methods. Okay, so going here, we have another external method here. And here we don't take any arguments here. But our end auction, as you can see here, this is how we're getting local state. So we're setting this variable equal to the value stored in our auction end global key. Same thing for highest bid, same thing for owner, same thing for highest bidder. So we're getting all of these local state or global state values and saving them in local variables that we can later use in our logic. Again, sound like a broken record at this point, but again, we're calling set and get on your properties of the class to modify global state and retrieve it. And here's another external method, bid, and we're taking in, again, a payment transaction, and we're going to be using that to verify that the actual bid was sent correctly. And then here we can also pass in an account directly. So we can, if we look at previous bidder, you can see we have previous bidder.address available for us to use. So at this point, the actual logic in the contract or in the methods itself is basically just regular PyTeal, with the exception of your local state or global and local states being using these properties. And then you have decorators where, if you notice, we don't have to manually specify the router anywhere. Beaker just kind of automatically does that since we inherit from application. Okay, so that's the contract itself. And what's nice here is, since this is a class, if I have a different file that I want to interact with this contract with, in, for example, our testing Python script here, I can see that from auction import star, and that will give me this, where is it? That will give me this auction class here to use. So since it's a class, importing it will give us access to that class. And this is going to be an example of how exactly we use the app client for testing. So this file is using the Python SDK for, and Beaker, of course, for testing our Beaker contract. So first thing we're going to do is create a fixture here. If you're not familiar with PyTest, basically a fixture just means a helper method that we're calling before we execute an actual test. So here, before we execute any test, we obviously need to create the application. So we're setting up some variables. We're getting our accounts. Again, we're just calling sandbox.getAccounts to get all of our accounts. We don't need an additional helper method. And I'm sorting by amount here. You don't need to do this. I just like to do this so I know the creator is always the highest algo account. And then just getting our creator from this array, initializing our app client. So this is basically the code needed to actually create the application. We just set app client equal to client.application create, and this is the Beaker client.application create, and pass in the sandbox get algo d client helper method. We're going to pass in our auction contract that we defined over here, and we're going to specify the signer, and this array here is going to be automatically include the signer object. So if we just do creator count equals accounts.pop and signer equals creator count.signer, this app client will be able to sign transactions based on this creator account. And then to create it, app client.create. So again, the lines of code needed to actually create the application and send the transaction for creating it and submitting it to the blockchain is really, really low compared to what you would have to do with PyTeal. And we do similar things for our other method calls. So here we have start auction, and we're we do need to manually create our payment transaction, of course, because the ABI doesn't specify what that should look like. So we create our pay transaction here, and then we do a app.client call or app.client.call, and we're specifying that we want to call start auction, and then we're just passing our arguments like a regular Python method. No need for decoding and encoding, and dealing with all that sort of stuff as well, which is really nice. And here's another fixture, again, pretty much the same thing. We're getting our payment transaction, uh, and we're basically doing another app call, calling auction.bid this time. And here's a fixture for sending a second bid. So basically the same thing as the first bid, except we're going to be sending a higher amount. So this is all the code basically for setting up this auction contract, for sending bids. All of it's kind of done. All these fixtures done in under 100 lines of code, and um, now we're ready to just write our tests. And when you're writing tests, it's good to be as deterministic and as simple as possible. And this is what Beaker really allows you to do. So if we go down to our actual test here, we can see um, one of the things we can do here is call app client. So if we go back up, again, our app client is just set in this, where is it? In this fixture. This is a global variable. So we only need to initialize the app client once here in our create app fixture. And then from there on, there outwards, we can just interact with that through all of our tests. So here we're testing that the owner is going to be equal to the creator account address, right? Very, very simple testing here, where all we need to do is do app client get application state to get our global state, then encode the address, and away we go. And it's same thing for all our other tests here. So here we just have a simple one-liner since we're not working with encoding addresses. We're doing app client get application state, highest bid equals 0. Um, and here we're checking bytes. Again, you don't have to like worry about encoding and stuff. The app client does it all for you. So running your test, generally you can do like single or like just a couple of lines for very basic assertions on global state, for example. And you can do the same thing here, where now we're calling start auction, and we're checking the values in our global state once again, much like we did earlier. And we're just going through it, basically doing the same thing, doing app client get application state and ensuring that it's the expected value. And again, we don't need to manually worry about encoding or anything like that. Uh, the app client will take care of it for us. So hopefully what this shows, even if you're not super familiar with PyTest, this shows kind of how easy it is to write tests with Beaker. And if I go over here, I just run this. I don't have my sandbox running. Give me 1 second to load up my sandbox. Okay, not sure why this is hanging. Let's try and see if it works now. Yep, and there we go. We have 12 pass tests in 1 second. And as you can tell, that is a pretty streamlined way of testing a contract. It's so much better than manually testing using just the STK. And this is really the value of Beaker. Like if you're not convinced, right? If we were to take a look, there's some quality of life things like just being able to inherit from the class, setting your state just as properties. Those are all really nice. And if you go down here, where is it? You can just call app.approval program, clear program. Like those things are nice to have and make writing a contract easier and also a little bit more type safe. But the real value of Beaker is scenarios like this where you can use it to interact with the contract with a few of lines of code um, as necessary. So that's kind of where the value, really kicks in for Beaker. And if you notice, everything we've done so far is in Python, but we also have a application called Beaker TS. So here, let me do an npm I. So this here is our TS test directory um, in this repository. As you can see, we have a source and we have a Beaker folder, Beaker directory. But right now, nothing is in here. So if I do code package.json, first, let me show you a dependency here. Our only dependencies are algo SDK and then this Beaker TS package. So what Beaker TS does is it provides this really cool Beaker CLI tool. So if I do npm run Beaker, this will call auction.py, which compiles a contract, and then just calls Beaker generate, and it's going to take in the app spec. So this is different. So this is our API JSON spec, and this is our app spec. The app spec basically contains the API JSON spec within it, but it also contains additional information such as the approval program, clear program, the schema, the global state, stuff like that. So the app spec is basically like an extended version of the API spec that tells Beaker TS what our application actually looks like. But if we go here, we can see when we ran this Beaker generate source Beaker in source Beaker, if we go over here, we now have this new TypeScript file. And this is really cool. This is auto-generated code for the app client. So this is our application client for the auction. So now in our tests, if I go over here in our TypeScript file, you can see that I import auction from Beaker auction client, and then we use it like pretty much the same way as we did in our Python test, right? You can see here, we do app client equals whatever, and then app client.create. Here we do auction app, and there's some abstraction here since we specifically know it's auction. We don't do app client.create. We can just do new auction. So this is literally just a class that we initialize. And again, we have our Beaker sandbox method. We have the signer exposed via our sandbox account, and then we just call auction app.create. And it's that simple. So again, here we're setting up our app client, calling create, really same thing in TypeScript. So what this Beaker TS package does is provides a tool to generate the app client in TypeScript so that we can use it. And if we take a look through our actual test here, so this is our create auction app. This is basically the equivalent of our fixtures that we had in PyTest. We can see that we have our create auction helper method for actually getting the app ID. We have our start auction. And you notice here, this is a cool thing. You can, rather than saving the um, app client as a global variable, what you can also do is just initialize new app client with a specific app ID. And this also allows you to change like the signer and the sender and everything as well by default. But you can specify the app ID so you don't need to go through the creation process again. And again, so this is our start auction method. Similar to Python, we need to manually construct the transaction to pass, but then we can just call auction app start auction. And if you look, all of our arguments are typed here, which of course is really huge for working with TypeScript. We have everything properly typed and knows exactly what to do. It's type safe, and same thing applies for our other methods as well. We have send bid, and then if we look over here, we have our test defined similar to our PyTest test, where we're basically setting our state, and then we're going through and right doing our assertions. Right, we're expecting the auction end to be 0, expecting highest bidder to be an empty string, so on and so forth. So what Beaker really provides, again, is this application client, and this is not only available in Python, but it's available in TypeScript through the Beaker TS package. And to install it, you just do like a npmi Beaker TS, and I already have it installed, but that's how you install it. It's that simple, and then you just call this Beaker generate, pass it the app spec JSON. You can also pass it the ABI JSON, but you'll lose some information there. So if you're developing, definitely use the app spec JSON if you can, and then specify the output directory, and away you go. And then you can just import it and use it in your tests or in your front end code. And speaking of front end code, one last thing to show in this repository is how it looks like for web. So again, if I go over to our web directory, let me do an npmi. This is a directory setup similar to our TS directory, but this is specifically for a front-end web interface. So as you can see here, we have our dependencies using Beaker TS. Go to our scripts. We have our same sort of like Beaker. So if I do npm run Beaker, first let's take a look at the source Beaker. That's empty. npm run Beaker. Bing. We have our auction, and then we can import it here in our front-end code. And npm run serve. Open up. If I'm not a Web 2 developer, so a very basic UI here. But if we look under the hood at what code we're executing here. Nope, that's the wrong spam email. Okay, so if we look at the code that we have here, we can see first, let me take a look at the index.html. Very simple. We just have a couple of buttons with their own ID, a couple of inputs with their own ID. And then again, not a Web 2 developer. So if you are and you're looking at this code and cringing, I apologize. But if we look over here to our index.ts, what we're basically doing is setting different functionalities for our own clicks. So here, when we hit the connect button, we're going to connect through MyAlgo. When we do the create button, we're creating our auction app and setting our app ID. And then we're creating the auction app client, calling auction app.create, and then getting the app ID from that. And then for start, so this is our start auction. Again, same thing, creating the auction app client, passing our app ID, constructing the payment, or constructing the app call, and starting the auction. So same thing for bid as well. So we also have, I should mention some additional logic here for getting the previous bidder, but basically it's the same kind of code you do in a test. The main difference here is that if we take a closer look at our auction app here that we're creating, so we are passing first for our client, we're passing algod client. So if I go to the definition, this is a client that's pointing to the algo node test.api. Then if we also go here and look for our signer, like if you remember before, we were doing passing creator account.signer. But since we don't have a predetermined creator, what we're basically doing is calling this signer method. And all this signer method does is constructs or takes in the transactions, passes them to MyAlgo, and then returns the binary transactions. So if you remember, actually, let me just take a look. Right. So and here our signer is just the creator account sandbox account has the dot signer method. Whereas here we're specifying our own signer method that passes it to MyAlgo. And then so this signer method and this custom algod client to testnet. It's really the only differences you need for testnet. And if I were to open up um, this demo here, you just do connect. Connect accounts, choose who I want it to create it with, create the app, ask me to sign it. Just got to wait for it to go through. And once it does, here we have an application created based on that Beaker TS app client. And we can see initialize our state properly and save the owner rights, set all our other values as we expect. And that's basically it. So that is what that is basically all the code you need for your front end when you're comparing it to like the back end testing is just the algod client in your custom signer method, and then you can just implement it, um, implement it directly in your front end code. So again, kind of the whole value of Beaker is just making this sort of integration, right? The integration of actual interaction with that contract as easy as possible. And if you want to, try this out for yourself, and again, um, you go to github.com/algorand-devrel. Want to take a look at the first repository I showed. It's the Beaker calculator repository that shows PyTeal and Beaker, and you can go through that. But this specific demo, this auction demo, you can go here to Beaker auction and take a look through the different repositories, and we have all the instructions for how to run this here if you want to get hands-on and start playing around with Beaker. And if you want to know more about Beaker, you can also check out, here is the Beaker repository, and then we have the documentation linked here as well. This is a great resource for just learning about the basics of Beaker and everything that it has to offer, and also do some more advanced things like logic signatures. But the Beaker auction, or the Beaker auction repository, is a great place to get started. And then also here directly in the Beaker repo, you go in examples. We have a ton of examples here that are available to look through. So if you're just getting started on Algorand, if you're just getting started on Algorand and want to develop contracts, where you want to end up is Beaker. And kind of a prerequisite of Beaker is understanding PyTeal. There are some PyTeal things like the router, um, global state that is abstracted away in Beaker. But in general, you want to be very familiar with PyTeal, or not very familiar, right? You can write out basic contracts with Beaker without an intimate knowledge of PyTeal, but you basically want to be somewhat familiar with PyTeal syntax so you can actually write out your logic. And then let Beaker do a ton of abstraction on top of that. And here, one thing I should mention is that everything I talked about here is just in the respective repository. So, like the Beaker TS is in the npm repo, Beaker is in pip, and it's really easy to install. And finally, our Beaker TS repo. And as you probably have noticed, just me sharing my screen, if you go to itself, both Beaker and Beaker TS have these like warnings about it being experimental. So, you know, do keep in mind that this is still something pretty early in development, but uh, the simplicity it creates and how easy it makes writing and interacting with smart contracts, uh, just it's kind of strongly recommended to get started with it, even though things are subject to change. You might run into a bug or two here or there, but for the most part, it makes writing contracts way easier, and it's what I recommend to most people. So that concludes kind of the overview for Beaker. If again, if you're not familiar with PyTeal, I recommend checking out our Intro to PyTeal session that we did for Greenhouse Hack 2. earlier this week. And then also check out our learning resources, which we have a recorded session on. And then links, if you're watching this on YouTube, will be in the description. And of course, if you have any questions, feel free to reach out to me on Discord.
Awesome. Thanks, Joe. I'll take a pause here in case anyone has any questions. But if not, I just wanted to say thanks for taking the time to go through that for us. It was really insightful. And yeah, hopefully if you do have questions, just reach out to the Algorand team on Discord. That's usually the best way to get in touch with them. Other than that, tomorrow there'll be an ideation session that I'll be leading. And then there's one more session on Monday that Annalisa will be leading. And then we'll be really at the start of the hackathon. So I'm super excited for that. Hopefully you guys or you all enjoy getting some practice work in right now over the weekend and getting more familiar with the tools. And then the hackathon starts in a couple of days. So until then, I will see you next time. Thanks again, Joe, for walking us through this. This was helpful. And we'll see you again next time.
All right. Thanks, Gloria. Thanks, everyone, for watching.
Yeah. Bye, everybody.